Right, so we're starting Unit 4 today. We're looking at a bunch of different things in Unit 4. Unit 4 was kind of our, I don't want to say dumping grounds, but sort of dumping grounds for everything else that we have to cover. So we're going to see some more equations. We're going to see a shift into looking at conversions. And then some geometry stuff. So there's going to be a little bit less of an overarching theme in this unit than we've seen in the first 3 units. But the nice thing is that a lot of what we're going to be doing in this unit is stuff that you probably use on a more regular basis in terms of math. So, oh wait, you guys can't see anything. That's why. Now you can see. So the first thing we're going to look at in this unit is solving proportions and equations for percent problems. So the first one that we'll look at is a percent proportion. And it's a proportion in which one ratio is written with a denominator of 100. So we have seen proportions already. We saw proportions back in Unit 2. Do you guys remember how we solve a proportion? Good, with cross multiplication. A proportion again is when one fraction equals another fraction. What we're going to see here is that one of our fractions has a denominator of 100. So we set up our percent proportion like this here with the amount over the base equals a percentage over 100. Now, a couple of comments here. The base often follows the word of. So when you're pulling the language or pulling the pieces out of the problem, the base, whatever the base is, it's what's following the word of. And the amount, it's what's being compared to the base and is often before the word is. So there are some cues in defining those numbers as we go. So for this first example, we're going to set up our proportion. We're just not going to solve it. So 20 miles is 20% of 60 miles. I think it's pretty clear what the percentage is. So I'm going to use some different colors. We'll use pink for the amount, blue for the base, and green for the percentage. In this problem, the percentage is 20%. Which is the base, the 12 or the 60? How do we know it's a 60? It follows the word of, good. And the amount is what usually comes before the word is, so that's the 12 miles. So if we're setting this up, it's going to be 12 over 60 equals 20 over 100. And notice we don't have any variables yet. We're just working on identifying the pieces of that proportion. Okay, the next one. I think the percentage is usually the easiest to identify because it's a percent, it's the only percent. So starting with that, the percentage is 14. What is the base? The 600, good. Which means that the 84 is the amount. So 84 over 600 equals 14 over 100. Questions? Okay, try the next one on your own. What's the 32? The amount. What's the 2000? And the 1.6 is our percentage. So this looks like 32 over 2000 equals 1.6 over 100. How are we doing? Doing okay? If there was an unknown in this proportion, we would solve it with cross multiplication. So we're going to set up our percent proportion and then we're going to solve. What is 82% of 250? Again, identify the value. So I'm going to use those same colors. So green is our percentage. What's the 250 represent? The base. What are we trying to find then? Which is our variable. So it's going to be x over 250 equals 82 over 100. Let's move that up. We solve this with cross multiplication. Again, it doesn't matter which diagonal you multiply first. I like to have the variable on the left, so I just pick whichever one has the variable first. So 100x equals, what's 82 times 250? What's 82 times 250? Good. And how do I solve for x? $205. Does that answer seem reasonable? Why? You're going to have to explain more why you think that makes sense. Would be what?
Well, it is that, but I mean, it seems reasonable.
Why is it reasonable?
Because if you cut it to 50 in half, that's 50%. It's going to be higher than the half.
Okay, but what? So yes, we know it's going to be more than half of 250, but what is also going to be less than? Which is what? 250. Because we're only talking about 82%, 82% is less than 100%. So I know that my answer should be less than 250. Now it does, I mean, it's good that we observe that it should be more than 50%, which is the halfway point or the half of 250. But one of the things that I notice a lot of times with students is that if they mix up what the base and the amount are, then all of a sudden the problem is all sorts of out of whack. So understanding what your unknown is and how it relates in terms of whether it's greater than or less than the other values is important. 21% of what number is 42? Here's my percent. What does the 42 represent? The amount, good. So this, what number is our base, isn't it? So now our equation or the proportion, notice we're setting up the proportion every single time the same way. Amount over base equals percentage over 100. So amount is 42 over the base, which is x, equals 21 over 100. And then we cross multiply. Again, I'm going to multiply the diagonal that has my variable so that the variable's on the left. So I have 21x equals, what's 42 times 100? Good. Does that seem reasonable? Is it reasonable that 21% of 200 is 42? 21% is less than 100, so the amount should be less than the base, which is what we have here. Okay, try this one on your own. Just set up the proportion. You don't need to solve yet. What's the 48? That's our base. And the 15? Our amount. The unknown is our percentage. So 15 over 48 equals x over 100. And we cross multiply. 48x equals 1500. What does x equal? Does that seem reasonable that $15 is about 31% of 48? Yeah, that seems reasonable. Does our amount always have to be less than our base? Not necessarily. Questions on how to set up these percent proportions? We're going to do the exact same type of problem, but now we're going to set it up in a little bit of a different way. Now we're going to set it up using a percent equation. It's solving for the same exact thing. It's representing that proportion. It's just representing it in a different way. So if we see this example, and I'm going to point to this, okay, looking at C, there's my proportion, right? When I cross multiplied in this line, I got an equation. So this and this right here are exactly the same thing, aren't they? What we're going to be doing down here is starting at this step, not this one. Okay, so let's think about it. This is always my base, that's always my percentage, this is always my amount, right? Now, this percentage is being divided by 100. So when we look at our formula here, amount equals percent times base, the percent is always in decimal form. Because if we think about that proportion, if you take your percentage and divide it by 100, that converts it to its decimal. Again, the base always follows, or often follows, the word of. The amount is often before the word is. Not always, but a lot of times. The big difference between using a proportion and using the percent equation. With the percent equation, you want to convert your percentage to a decimal. In a proportion, you do not. So setting up our percent equation, 80%, that's our percentage. But what are we going to plug in? And we're not going to use 80%. What are we going to put in? 0.80, good. of what number is 94? What does the 94 represent? And that base is our unknown, right? So back here again, amount we're going to use pink, green for percentage, blue for base. So our equation looks like 94, sorry. 94 equals 0.80 times x. How do I solve for x? Z? Divide both sides by 0.80. Is this reasonable? Is it reasonable that 80% of this 117.5 is 94? Yeah, 80% is less than 100%. 94 is less than 117. What percent of 150 is 213? So the percentage is now my unknown. What's the 150? And the 213? Before we start setting this up and solving this, what do we think is true about the percentage? It's going to be over 100. Why? Good. Now we have a situation where the amount is bigger than the base. So that indicates that we're dealing with more than 100%. So the amount equals your percentage, x, times the base. Divide both sides by 150. What is the value of x? Z? Good. Now, is this 1.42 a percentage? No, it's the decimal equivalent. How do I convert from a decimal to a percentage? Or move the decimal over. Mm-hmm. Notice in my first version of x, and this one right here, I didn't have a percent symbol. It wasn't until I multiplied by 100 that I added that percent symbol. (235% of 60 amounts to what number? Here's our percentage. What are we going to plug in for the percentage? Good. We're taking that percentage and we're moving the decimal 2 to the left or dividing by 100. What's the 60? The 60 is our base because it follows the word of. And the amount is what we're trying to find. What do we know about the amount? It's going to be more than 60 because we're looking at 235% of 60, right? 100% of 60 is 60. Less than 100% is going to be less than 60. More than 100% is going to be more than 60. Does that make sense? These thoughts, guys, these are important just to make sure that our answers are correct. Because if you set these equations up incorrectly, it's going to be really obvious, right? Your answers, you're going to be able to look at your answer and be like, that doesn't seem reasonable. And then you know that you've switched values. And again, it's usually the base and the amount that we switch because those are in the same units. So X, our amount, equals our percentage, 2.35 times the base. X equals 141. If it's 235%, that's more than 2 times the original amount, right? So 2 times the original amount is 120, so we know it's more than 120. Questions? So of the 4 ladies that are here, based on the few examples we've seen, which method do you prefer, proportions or equations? Okay. Yeah, I mean, identifying the values from the problem doesn't change. It's how we set it up then that changes.
I prefer the equations because you skip the whole step of having to put it in the proportion.
Okay.
And the percents are in decimal form.
Okay. Z, do you have a preference? Proportion? What about you, Karen? Doesn't matter. So you got 2 for proportions, 1 for equations, and 1 that doesn't care. And that's fine. What I'm telling you right now, guys, is that these problems that I'm going to ask you to do on quizzes and tests, I don't care how you choose to set it up. If you choose to use a proportion, use a proportion. If you choose to use an equation, use an equation. I don't care.
I feel like I'm even on a test or something, I'm more likely proportions though, just because that's like.
And it might, so. Well, so I think I'm more in the same boat as Karen. Like, I don't really care which way to do it, but there are certain problems that when I read it, like my mind just instantly sets up a proportion, and there's other problems where I set up an equation, and it's weird, and I can't explain why. Certain problems I go one way and certain problems I go another way, but it happens, and that's okay. You are going to have to set up those equations or proportions with an unknown. That first step is required. It's not optional. Okay. One of the things that I see a lot of times when we get problems like this, because you guys have dealt with percentages like a lot in the last, several years of your life, right? We deal with percentages all the time. And what we're going to go to next class is looking at all these different types of percent equations that we've seen in different, or in various situations in our lives. But a lot of times what we do when we start dealing with percentages is we just grab our calculator and start doing some calculations. What I want you guys to make sure that you're doing now and in your homework is that you always set up that equation, because that is going to be a requirement on the exam. Whether it's a proportion or it's like the equation form, I don't care. Whatever way makes you happy, but you have to have that percent or that equation or that proportion. So the last comment I have on that, when it comes to Alex might say, set up a proportion and then solve. Does Alex know that you set up a proportion? No. They know that you solved it and you got the answer. So if Kalika, you're like, I really just prefer the equation method, and the directions on Alex say use a proportion, set up an equation. If that's what you'd like to use, because it will always work, right? either method will, well, I wouldn't say proportion always works. We're gonna, in our next couple sections starting on Thursday, we have like set kind of equations, if you will. But like for these problems,
Yeah, I think it's good to practice both.
I would agree, but I'm just saying, I'm not gonna require you to show me both.
Regardless, doesn't matter if like the proportion of the equation, I'll get the same answer that you correct.
Mm-hmm.
I don't care.
What I was saying though is when we get into our next lecture, we're gonna introduce a bunch of new like specific percent equations. So like how to find tax on a product. Well, it's the exact same equation that we saw here, amount equals percent times base. We just call the amount and the base different things now. So again, it can all be set up exactly the same way using a proportion. It's just whether or not you're gonna make that connection. Okay.
Maybe I should learn since we're gonna.
I mean, you can maybe just wait until we get there and see how it is there. Because if you practice proportions now because that's your preference, you might get really good at it, and then you will get really good at it. And then when you see these other percent equations, you might be like, oh, well, that's basically the amount, and that's the base, and that's my percentage, and now I can just plug them into my proportion. You don't necessarily have to have this other formula, right? Okay, so these directions are exactly what the directions on your quiz and your test look like. Set up a percent proportion or percent equation for the following scenario, and then solve. So you have to set up this form of an equation, right? Whether it's a proportion or just a regular equation, it's up to you, but you have to set one up. In a recent year, it's estimated that 24.7% of US adults smoke tobacco products regularly. In a group of 2,000 adults, how many would be expected to be smokers? So let's identify the different parts. The 24.7 is our percentage. What's the 2,000? It's our base. And we're trying to find how many would be expected. What's that going to be? What's our unknown? The amount. All right, so again, we have started every problem the exact same way by identifying what's the percentage, what's the amount, what's the base, and then we're substituting into whichever model we like, whether we like the proportion model or we like the equation model. You plug into whichever one you want. I'm going to show both. Okay. Kalika, did you do equation?
Mm-hmm.
What does the equation look like?
X equals 0.47.
Selena, did you do a proportion? Z, did you do a proportion? You think? Okay, well, let's see what you did. What did you get? Perfect. That's perfect. So now you guys solve them. Solve whichever one you set up. I mean, it maybe takes away one extra step, but I don't know. I mean, we're talking about very insignificant amounts of time that we're saving.
Yeah.
If one makes more sense to you, then do that, you know?
I want to learn equation.
Okay, well then my challenge for you is to set up an equation for the next one.
I'll set up a proportion.
Perfect. You guys are trading. What does X equal? Does that seem reasonable? We're trying to find about 25% of 2,000, aren't we? That's all we're doing, is we're adding a bunch of extra words. What this question is asking for is, what is 24.7% of 2,000? That's exactly what this question is asking us.
Sometimes, like on tests, if they're worded really strangely, like that my mind just can't like process it, I'll rewrite it like how you.
Yep, you simplify it. You're like, let me just eliminate all this extra fluff, right? All this bedazzlement. Yep. It's not there to confuse you. It's there to make it so that it's like, oh, this is how it actually looks in the real world, right? This is a real life application. Finding 24% of 2,000 has no application to it. Are you guys okay that I'm not showing the steps of solving? Yeah. Okay. I figured as much. 8 students in the statistics class received a grade of A in the class. If this represents about 31% of the class, how many students are in the class? Round to the nearest student. Okay. So what's the 31% is our percentage. What other value are they giving us?
8.
Good. 8 is the number, and what does it represent? So read the whole question again and see if that makes sense to you. 8 is the amount. Amount equals percent times base. Yeah. All right, Z, what'd you get as your equation? Okay.
So 8 equals 31 times x.
Close. When we're using the equation, what do we have to do with that percentage? Kalika, did you do a proportion? Okay, how does it set up? How does the proportion set up?
800. Oh, 31 over 100, 8 over x.
So I just wanted to be very clear. So consistent with the way that the proportion is set up in our notes. So it's amount over base equals percent over 100. But if you change those two fractions and you put percent over 100 equals amount over base, that's fine. I mean, the two different sides don't matter. But the way that we structure them, amount over base, percent over 100, that does matter. What is X?
You want us to round up?
Well, it says round to the nearest student.
Yeah.
26.
What do you mean rounded? I got 0.26.
You had 26 or 25.8?
Yeah, so I put 0.26. So
Not 0.26,
26.
just 26 students. So again, thinking about what we're solving for how many students are in the class, right? You'll see a lot of rounding rules, and we tried to be very clear and make sure that it was, we mentioned in every problem how we wanted you to round. But in certain things, when we're talking about like the number of students, we can't have a fraction of a student, right? So we're always going to round up to the nearest student. There were 425 donations made for various dollar amounts at an animal sanctuary. If 60 donations were made in the 100 to 199 range, what percent does this represent?
So the amount is 425. No,
60 is the amount. The total was 425, right? So that's our base. Our unknown is the percentage.
Oh yeah, I forgot your video.
Karen, what did you set up? Okay, so Karen set up a proportion. What was your proportion?
60 over 425 equals x over 100.
Good. Selena, what are you working on? You did a proportion. Did you get the same one? Good. Okay. Z, what did you get as your equation? I didn't give you anything. Now, the only thing that I could see is putting the x before the 425, since it's like, well, again, when we look at that model, it's amount equals percent times base. It doesn't really make any difference because once you solve the multiplication, doesn't matter what the order's in, right?
And it says round to the nearest
10th of a percent, yes. All right, so let's work over here on this equation part. When we solve for x, we get 0.14117, right? But that's not a percentage, is it? So how do I get to a percentage? By multiply by 100, good. So if I multiply by 100, and now I round to the nearest 10th of a percent, how many decimal places is the 10th place? 1. Yep. So 14.1%.
Some last for the 100 to the 100 for some last.
So we've talked about the advantages and disadvantages of proportion method versus the equation method. The equation method maybe seems like fewer steps to solve to find the value of x, but when we're solving for an unknown percentage, the equation method, we have to take one step further after that, don't we? Whereas if I solve the proportion method, my answer is just going to be 14.1 and I'm done. I don't have to do any conversion from decimals to percentages because of the way that the proportion is set up. So, and that's wonderful. Like if we get to the point where we recognize like, ooh, we're looking for a percentage, so proportion might be easier because it's already like the percentage is already as a percentage, not as the decimal equivalent. That might be wonderful, but we don't have to get there necessarily. We don't have to see that. If we like one method over another, that's fine. But there are things that we need to recognize in both of them, right? In a science class, 85% of students pass the class. If there are 40 people in the class, how many passed?
Wait. There's 40 people.
85% passed.
So 40 is base?
40 is our base.
She looked at me. So then amount is x? This one's easier in equation.
So why is an equation easier for this one, Kalika? Yeah, because the amount is our unknown and the amount's already isolated. I would agree. So x equals 0.85 times 40. What would it look like as a proportion? Awesome.
See, that one is easy as a proportion too, because I know I have to do it by 500.
I mean, I don't think that one is necessarily easier or more difficult than the other.
Yeah, I think they're both like, we both get to the same answer.
You do.
I don't know.
And I agree with you, Kalika. Knowing both is probably, I mean, being comfortable with both is probably your best bet, right? And ideally, that's where I want you to be is, yeah. Depending on, like, no joke, depending on what problems you've already seen, the day of the week, the time of the day, you might look at this problem one day and use a proportion. You might look at it another day and use an equation. I mean, there's lots of things that kind of factor into our decision-making process, right? So being comfortable with both methods, I think, is really our end goal. But we may not get there. So I'd rather you know one method really, really well than know both methods only sort of well. Does that make sense?
Well, I have 4.
Z, does it make sense why the 40 is the base when you reread it? So there's 40 students in the class. We want to know how many passed. So the how many passed, is that going to be greater than or less than 40? Less than 40. And although it's not always the case where the amount is less than the base, in a situation like this, we can't have more students pass than there are students in the class, right? There are some restrictions because of the context. So, and that, okay, so then you want to think of it, try to shift it in your mind. Base is the same as total. So maybe we write that down. Base is the total, not the amount.
Amount is what you're trying to get out of the base.
Mm-hmm. So, and this, I'm going to go back up here. So in this sentence right here, it says the amount is the part being compared to the base.
I didn't read that.
Brianna read 143 pages in a book. If this represents 22% of the book, how many pages are in the book?
So,
Go ahead, Z. I want you to talk me through this one.
so 22 is over 100.
Okay,
140.
that's fine. Well, before we start setting up the proportion, let's identify the pieces in the problem. Yep.
And 143 is the amount.
Good.
And X is how many pages are in the book.
Which is what? What does it represent in the formula?
Base.
The base or the total, right? If you want to use the word total, go for it. I'm okay with that. So then as a proportion, what does it look like?
143 over X is 22 over 100.
Perfect. Very good. Can someone give me the equation?
143
Good. What does X equal? Does this seem reasonable?
Yes.
Yeah. 143 sounds like it's about 22% of 650. Right? 22% is less than 100%. 143 is less than 650. So that makes sense. That seems reasonable. If Brandon had $90 in his wallet to take himself and a date to dinner and a movie, and he spent $47 on dinner, $26 on the movie, what percent of his money did he spend? So, and that's a good idea. So, read it to yourself, and at least if you need to read it to yourself more than once, my recommendation is one time read it out loud. The reason for that is that when we process information, we can process information several different ways. By reading it, we're processing it one way. If we read it out loud, we're also hearing it, which is another way of processing that information.
Would 90 be the base?
It is, good.
Total that he had.
Yep.
So that would be multiplied by.
Let's identify the different pieces. We need base, amount, and percentage, right? So that's what we're looking for. What percent? That's our X. So then they've given us the amount somehow. Good.
Add that up?
Yes. Yep.
So I was like, what do I do with that? You know what I mean?
Yeah. Well, think about that. He's spent both of those amounts, right?
Yeah.
And we want to know how much of the total did he spend? What percentage of that?
So then X.
47 plus 26 is 73.
So then it's what, 90 times 73? No.
Go back to your formula. What's the formula if we want to write it as a percent equation?
Amount. So 73 equals. X times 90.
Good.
That took me like 10 minutes.
It didn't take you 10 minutes. That's a gross exaggeration.
It took me like 2 seconds.
Yeah.
How did it in your head? You didn't say it.
Did anybody set this up as a proportion? Okay, Selena, what'd you get? I know.
So I got 73 over 90. And then X over 90.
Perfect. 81.1 what? Kalika? If it's a percent, do you need that percent symbol?
Yes.
Yes, you do. Yes, you do.
Do we want to divide them in full sentences? Also, because that's what I did. If Brandon spent 81.1% of his money.
I don't care.
Can you finish the how'd you get to 81.1 on the equation?
Sure. So we would take both sides and divide it by 90. So X equals 0.811. And then we multiply by 100. To get our percentage. Mm-hmm.
Did you give us our Unit 2 exam back, or did you just scan it to us?
Hold on. Yeah, I have it though. I can give it to you right now.
Okay. I was just, because I keep all of them in one spot. I was like, I only have Unit 1.
And I have the Unit 3 exams for you as well. Do we have any questions? Okay, we're done. So I'm going to pass out some stuff. So I think, Renee, you're the only one who's on. Yeah, so Renee, I've got some other stuff that I'm passing out today, but I can get that to you next class. So thank you for tuning in, Renee, and we'll see you on Thursday.
Who's Renee? Oh, quiet one.